All right. Hello, everybody. Welcome to Math with Miss Leslie. I know that was a little bit too much energy, but I thought you guys could use it. So today we are Unit 5, which is graphing our trig functions. And today on day 5, we're going to talk about how to make an equation from a graph. All right, so when you're given a graph, how do you take the information that you have there and make it into an equation? So first we're going to review the parts of a graph, and then we're going to talk about how to do this. So I'm going to show you guys the steps, and then we're going to do a practice problem. So here we go. Okay. So first things first, we need to review the parts of our different graphs. All right, so if you look up here, we have, I'm not on the right page, so let me get there. Okay, so our different parts of our graph. So I have a sine function right here. So here's a sine graph. All right, so it's definitely important to know what each one looks like. So this graph right here starts at the midline, goes up, down, and then back. So it has kind of that S curve, S for sine. See how we did that? Yeah. All right, the second one is our cosine graph. All right, and this is your general shape for your cosine graph. So cosine is going to start up at 1, go down to the midline, keep going down till it hits the minimum point, and then back up to the max point. This is your standard cosine graph. And it has that nice C shape, C for cosine. See how I did that? All right, so that is important because you're not going to be able to make an equation from a graph if you don't know which trig function you have graphed there. All right, so sine will have the S shape. It starts at the midline, goes up, down, and then back to the midline. Cosine has that C shape. We start high, go low, and then come back high. Okay, now the different parts of our function. All right, so we've talked about this in class, right? But let's just go over this again. So A, that's our amplitude. All right, it's the same in both a sine equation and a cosine equation. That's the distance we are from the midline. So if you look at your highest point, all right, so on our sine graph, we have our highest point back to that middle line, our midline of our equation. That's our A value, which is what we call the amplitude. All right, and that distance is the same from the midline to the lowest point. That's also A. All right, so that's our A value. That's important because we're going to be looking for that when we start, trying to make an equation from our graph. Okay, the next thing that's important is that midline, is that D value. So that D value is that middle line of our function. So this line right here, this middle, that's our midline or our D value. All right. In our cosine graph, again, we have that midline. All right, that middle line right here. So that's our D value. All right, and we also have that same amplitude. So for amplitude, right, well, we'll do this in blue since we started doing it in blue, right? So it's our amplitude right here, and it's the same right here. All right, so that's our amplitude, that's our A value. All right, next thing we have is our period, all right, which if you're looking at an equation, you don't know the period, right? You know the B value, which isn't necessarily the period. This B value is what we call our frequency, or it's our horizontal dilation, all right? But we can use that B value to find our period, all right? Now, when you're looking at a graph, right, you're going to be looking for how long it takes from start to finish. So there, you really can't see the B value in the equation, like in the graph. All right. But what we can find is however long it takes us to go from start to finish. So start to finish, like one complete cycle, that's our period. So when we're looking at our graphs, what we're going to be doing is we're going to try, so if we think it's a cosine graph, we're going to try and find a high point, and then we want to see how long it takes us to get to the next high point. because that's one period. All right, with sine, it's a little bit more complicated. So sine has the first point where we are like kind of at that midline, and then it does a high and a low, and then it goes to the midline. But it actually hits the midline, right? We see right in the middle here. All right, but that's not a period. That would only be half. So for sine, we need to go up, come back down, and then back to that middle line. So that's a period. All right, and we've talked about this in class. Your period is equal to 2 pi divided by that b value. So that's where the b value comes in. So the period equals 2 pi divided by that b value. Okay, so the b value isn't necessarily in the graph, right? But we can find it from a graph if we can find the period. So how long it's taking to do one full cycle, right? The last thing that we have is that c value, which this is our shift, our phase shift, where our first point is. So once you find, so if it's a cosine graph, right, you're looking for where do we have that first high point, that first point that's up at the max. Whatever this x value is, that's your c value. All right, so if it's at 0, then that means your c value is 0. If you have your graph starting over at, say, like 90 degrees, then your c value is 90 degrees. All right, so that c value is coming from where is that first point located at what x value. All right, with sine, right, our first value is when it's at that midline right before it goes up. So this is our c value, right? So that's what we're looking for. All right, so those are our parts of our equation. All right, so that's kind of what the graphs look like, where everything is located on the graph. And now we're going to go through the steps for figuring out the equation given that graph. But hopefully you can kind of see where we're going here. All right, so step number 1 is to always locate the midline. All right, so when I'm doing this, I think it's just the easiest thing to find first. So step number 1, when you're looking at a graph, the first thing you want to do is you want to locate the midline of the function. All right, so locate the midline. All right, not only does that give you one value for your equation, it also gives you kind of the center of your function. It's going to help you then do the second step, which is figure out your amplitude. All right, so locate the midline, right? This is going to give you the d value. All right, step 2, we're going to use the midline to find our amplitude. So use midline to find amplitude, which is your a value. Okay. All right, so that's going to give you, we now have 2 parts, right, of our graph. All right, the next thing we want to do, so step 3, once you've located the midline and you've used the midline to find your amplitude, the next thing you want to do is find your starting point, because that's your phase shift. All right, so determine the starting point of your wave. All right, so determine the starting point. Right, that's your c value. Right, whatever x value you're starting on, right? So if it's a sine function, remember you're looking for when does it cross the midline and then immediately go up after that point. That would be your starting point, right? If it's cosine, you're looking for it to be at the highest value. That would be your starting point. So that whatever x value that is, that's your c value. All right, step 4 is using that starting point you've now found, right? We want to figure out how long it takes to get back to that starting point. So how, figure out where your next point, your like ending is going to be. All right, so step 4, determine your ending point. The ending point. Okay, so this one's got a little bit more than just like one sentence. So you have to determine your ending point, all right? Because we have to use that formula, right? So determine your ending point, all right? Find the distance between starting and ending, that's your period. Okay, so that's going to equal your period. All right, so you find your starting point, you find your ending point, you subtract them to get the difference, the distance between the two. That's your period. Okay, so whatever distance you get between starting and ending, that's the period of your function. Now, to get the b value, you're going to do the b value will equal either 2 pi or 360 if you're in degrees, divided by that period. All right, so that's how you get your b value. All right, so we have step 1, locate the midline. That's the d value. Step 2, use the midline to find your amplitude. That's the a value. Step 3, determine the starting point. That's your c value. That's your phase shift. And then step 4, determine your ending point and then find the difference between starting and ending. That will get you your period. Once you have your period, to get the b value, you do 2 pi or 360, depending on if you're in degrees or radians, divided by that period that you got. And that's going to get you your last value for your equation, which is the b value. Okay, so now we're going to do an example. So there are steps. Now we're going to do an example. All right, I wanted to be able to see all of our stuff. Hold on, we can. I'm going to fix it. No. All right, we'll just zoom out a little bit. Hopefully you can still see the graph. There we go. I just wanted to have all of our steps so we could see the steps and we could do the problem. Okay. So step number 1, find your midline. All right, so I need to figure out what is exactly in the middle of my thing. So my highest point is 3. My lowest point is -5. All right, so highest point is 3, lowest point is -5. I need to figure out what is in between 3 and -5. Now, you could just count or you know, kind of figure it out on your own, but just to be safe, the easiest way to kind of do this is to just do the midpoint or the average. So you're just going to add the two numbers. So 3 plus -5 and then divide by 2. That's going to tell you what's in between those 2 points. All right, so 3 plus -5 divided by 2. 3 plus -5 divided by 2. Right, so -1 is my midline. Hold on, I'm going to do this and make it a little bigger. There we go. That's maybe a little easier to see. All right, so y equals -1 is my midline. All right, so I have my d value, -1. Okay, next up is to figure out my amplitude. So I need to go to the highest point and to the midline. And I want to know the distance between that highest point and my midline. So you can count if you want, or you can, you know, do subtraction. 3 minus -1 is going to tell you the difference between the two. Or you can just count. So like we got 1, 2, 3, 4. All right, and then just to make sure, this should also be the same. All right, midline to our lowest point should be the same thing. So again, you can count. So you're down 1, 2, 3, 4. So that's our amplitude. Hold on. I'm dying. Okay. I think I'm better. Whew. I swallowed weird. Anyways, I was too excited about math that I forgot how to swallow. Okay, so my amplitude is 4. All right, next thing we're going to do is determine the starting point. So I'm looking at this graph here, and I'm trying to figure out, first off, what type of graph is this? I can't figure out my starting point if I don't know what kind of graph I'm dealing with. All right, so I'm going to go to 0 because that's like the easiest place. That would be really nice if I just started at 0. So I look at 0 and I'm at a high point, right? So like I'm at the highest point at 3, right? So I'm at 3, +3 when I'm at 0. That tells me that this is probably a cosine graph because cosine, if you scroll back up to the top, starts at the highest point, right? It starts up here. So I'm going to then say that this is a cosine graph. All right, well, I know the general shape of cosine. All right, so I need to go down and then come back up. All right, so I went down, came back up. All right, so this right here is the starting point for my graph. All right, so I'm going to say my starting point is at 0. So my C value is 0. So I don't have a phase shift, which is nice. All right, now to figure out the distance between my starting point and my ending point. All right, so here's my ending point, right? So starting point is at 0, ending point is at pi over 2. So I subtract, now because it's 0, it's kind of nice, right? So you take your ending point, pi over 2, you subtract your starting point, all right? So I know that it's 0, so it's kind of easy, but we would do this if it was not 0, right? So pi over 2 subtract 0, that equals pi over 2. That's my period. All right, so that's how long it takes me to do one full cycle. It takes me pi over 2. All right, so I have my period, which is pi over 2. So now I need to calculate the B value. So we're in radians. So since we're in radians, the B value, so we'll do it right here. So the B value equals 2 pi divided by my period of pi over 2. All right, so I'm just using that equation in step 4. The B value equals 2 pi divided by the period, and my period is pi over 2. So I'm going to simplify this. So 2 pi divided by pi over 2. All right, when I do division of fractions, I keep the first fraction, I flip the second fraction, and I change it to multiplication. All right, so this is going to be 2 pi times 2 over pi. All right, when we multiply fractions, we multiply straight across. So we have 4 pi over 1 pi. So the pi over pi simplifies out. And I'm left with a B value of 4. So that's my B value. All right, now I can make my equation. I have all the parts, I can make my equation. All right, so y equals, all equations start with y equals, so yes, you should have the y equals part. All right, let me move my thing. There we go. All right, y equals, all right, my amplitude is 4, so it's 4. This is a cosine graph, right? We talked about this. So it starts high, it ends high. That's cosine. So 4 cosine, parentheses. My B value comes next, parentheses, x. All right. Now, my C value is 0, so you can put minus 0. You can get rid of that if you also want to. I'll write it without it. All right. Close your parentheses. And then my D value is minus 1. So this equation, so when I simplify, I get y equals 4 cosine of 4x minus 1. There we go. Now, you might be thinking, could you do this as a sine function? The answer is yes. It would just be a little harder. All right, so if you looked at this graph, and maybe you didn't start at 0. Maybe you just like the sine function more than you like cosine. That's okay. I understand that. I like sine better than cosine. I don't know why. I think it looks prettier. And you said, okay, well here, right here at pi over 8, I'm crossing my midline. Well, when's the next time that I cross my midline? So I follow it around. I go up, I go down, I go back to the midline. Well, right here, right, let me make that a little bit darker. I'll just use black. There we go. There you go, that's a little darker. All right, so that's a sine graph, right? That has the shape of a sine function, all right? And if we look at it, we still have an amplitude of 4. All right, so we still have that amplitude of 4. We still have a midline at y equals -1, so that stuff doesn't change. All right, but what does change, so let's do this. So let's do, this was for cosine. All right, so we still have that amplitude of 4, so we're doing sine. All right, we still have that d value of -1. All right, but now our starting point is different. So we started at pi over 8. So our c value, if we're doing a sine graph, would be pi over 8. So pi c equals pi over 8. Right, now our ending point is now at 5 pi over 8. So we do need to subtract. So we're going to say, okay, 5 pi over 8 minus pi over 8 equals 4 pi over 8, which simplifies to pi over 2, which is kind of funny because it's the same as it was for cosine, right? So period is also pi over 2. All right, so then our b value, now you don't need to calculate this by hand again because we've already done this, right? Our b value is going to be the same thing because the b value is 2 pi divided by the period. Since our periods are the same for both the sine and the cosine graph, then our b values have to be the same. So you would have done this on your own by hand, right? But since we've already done this for this problem, I'm just going to use what I did above. Okay, so now when we make this equation, there's two things that are going to be different. So first off, this is a sine graph now. All right, so we would have y equals something sine, right, parentheses. Oops. Parentheses. All right, another thing that's different. Do you notice how when we did the sine graph, we started by going down first? That tells you that it's a negative sine graph, right? Usually sine starts by going up, right? This one starts going down, so this tells us it's a negative graph. All right, so I should have a -4 sine. All right, my b value is still 4, parentheses, x. Now, it's not -0, it's minus pi over 8. So minus pi over 8. And then we're still going down 1. All right, so if you thought of this as a sine function, so if you looked at this and you noticed the sine graph first, then this would have been your equation. So yeah, there are going to be multiple answers to doing problems like this, and that's okay. All right, let's look at the second one that we have, and this is our last example. All right, so this is in degrees. All right, so step number 1, we're going to find that midline. So our lowest point is -1. Our highest point is 3. So we add 3 plus -1 and divide by 2. That's 2 divided by 2, that's 1. So my midline is at +1. So 1 is my midline. All right, for my amplitude, it's my distance between my highest point and my midline. All right, so that is going to be 1, 2. Just make sure it's the same here. And 1, 2. So it is. All right, so my amplitude is 2. All right, next I have to figure out my starting point. All right, so if you look at 0, we don't have a max point at 0, and we don't have it crossing the midline at 0. So we do have to have some kind of shift in our graph, forwards or backwards. Now, again, this depends on what graph you see when you first look at this, right? Because you could have a different answer than, you know, what I might get. All right, but to me, the first thing that I see, the closest thing, is where it crosses the midline right here at -180. So I see right here it crosses the midline. All right, so then I'm going to say, okay, so then I go down, come back up, and then I go down again to the midline. All right, that's a sine graph. All right, so I don't think we could do, with the information that we're given, I don't think we could do a cosine. So with cosine, you would need either a max or a min point, and then it has to go back to another max or min point. So the first maximum point that, or minimum we get to is this point right here, 180. But then it doesn't have another like minimum value. So I don't think we have enough information to graph this one or do this one as a cosine. This one we have to do a sine because we don't have enough information for it to be a cosine graph. All right, so we have to use that point right here as our starting point. Okay, so that starting point is at negative 180. So that's our C value, negative 180 degrees, right? We're moving to the left, okay? So that's our starting point. Our ending point is right here at 1260. Okay, so now we need to figure out the distance between those two. That's our period. So we're going to do 1260 minus negative 180. Right? We're trying to figure out how much is in between those 2 points. All right, so when we do that, 1260 minus negative 180, we get 1440. All right, that's our period of our function. So 1440 is our period. All right, so now we need to figure out our B value. So for the B value, we're in degrees, so we're going to do 360. So it's 360 divided by the period, which is 1440 degrees. So 360 divided by 1440, that's 1/4. Now we don't have degrees anymore.